This is the Brave New Coin Crypto Conversation, hosted by Andy Pickering.
Hi everyone, Andy Pickering here. I'm your host and welcome to the Crypto Conversation, a Brave New Coin podcast where we talk to the people building the future in the Bitcoin, blockchain and cryptocurrency space. My guest today is Sergey Nazarov. Sergey is the CEO at Chainlink, where he is helping to spearhead the smart contract oracle revolution. Sergey has been down the crypto rabbit hole since 2011, and Sergey believes that blockchain technology has the ability to change the way that societies distribute wealth, enforce contracts, and share and utilize critical information. Welcome to the show, Sergey.
Great, thank you for having me, Andy.
Sergey, I'm not going to delve too far into your own background because I think most listeners of the Crypto Conversation will be familiar with who you are. Very quick context. Blockchain started with Bitcoin. Bitcoin enabled digital scarcity, peer-to-peer digital payments, and Bitcoin is now understood as digital gold for now. Soon after, along came Ethereum. And the interesting thing about Ethereum is that it added additional programmability in the form of smart contracts, right? So smart contracts promise to make the world a little bit more efficient, but right now one of the main problems with smart contracts is that they aren't actually that smart. And we're going to get into all of this. Sergey, let's start with the basics. How do you explain a smart contract and why do you think they are a big deal?
Yes, I think a smart contract is basically, in terms of the value it provides, it's the most reliable form of digital agreement. Now, digital agreement is when you formalize some kind of agreement, legally binding or something technologically enforced, that usually controls some kind of value. And it's different in different industries. In the financial services industry, it's financial products. With ad networks, it's ad revenue. With insurance companies, it's insurance payouts. And with global trade, it's trade finance payouts and supplier payouts. But at the end of the day, what I think our space is about is it's about formalizing a digital agreement and doing that in a way that is extremely reliable. So what extremely reliable means is that you have a certain set of guarantees that that digital agreement is going to follow through on how it was written and what it's meant to do. When I think about the evolution of our space or different parts of our space, when you think about Bitcoin as a smart contract, it's basically an agreement about a technologically enforced agreement about ownership. Ownership of literally one thing, Bitcoins. And it's more reliable than other forms of ownership, basically because there's no entity that can stop you from owning it. There's no entity that can stop you from moving it around. And realistically, when you see other systems fail, that's when you actually start to appreciate the usefulness of a reliable system. What the other systems that have come since Bitcoin have been doing is that they've been expanding what can be made reliable, right? They've been expanding what categories of agreements can we make extremely reliable by having them be technologically enforced. And the most recent one that took on a large amount of adoption has been Ethereum's ability to make the creation of tokens a form of digital agreement that's relatively accessible to people, both from the point of view of generating the token, getting the token, securing the token, changing the token for another token. And because that capability was made possible by Ethereum, our space has kind of been redefined in this lens, in this category of economic activity focused on let's generate a token, let's have it represent something, and let's move that token around. My view is that the space has a lot farther to evolve, and that with the help of the work that we do on oracles and expanding what smart contracts can do, that's kind of the body of work we're involved in. But generally speaking, I see a smart contract as something that's extremely reliable. It's an extremely reliable form of automation. It's the most reliable form. Reliability for automation is actually quite important because when you think about what we're saying when we're saying automation of contracts, we're saying that we're going to control and release large amounts of value while eliminating people. And that's going to create efficiency and security and all kinds of benefits. If you ask somebody, do they want a more reliable system controlling value and administering it, or do they want a less reliable system? People are always going to want a more reliable system, especially as the amounts of value secured get higher.
That's right. And Sergey, we should point out that smart contracts are not a new idea. The smart contracts are not something that came along with the deployment of the Ethereum blockchain. The person that actually coined the term smart contract was computer scientist and cryptographer Nick Szabo, who most people should be familiar with, and he coined the term in an essay back in 1994. So in that essay, Nick used the example of a vending machine, right? So imagine a Coke machine. If you put $1 in, you get a Coke. That's a really basic example of how a smart contract works. A smart contract is just a set of predefined rules that execute if those rules or conditions are met. Nick took that example one step further. He used the example of a car loan payment. So if you have a car, you've bought a car and you're paying it off, and if you fail to make a payment on that car, a smart contract could programmatically revoke your access to that car. So we're not quite there yet, but we're heading in that direction. So really the big idea for smart contracts is to evolve contracts and contract law and take the human component of trust out of the system. That's what you were talking about before, and automate the whole process, right?
I think there's a slight nuance. I'm not sure if it's going to update contract law as much as it's going to create a parallel technologically enforced method of agreement. Right. So you might have parts of the world where the legal system doesn't actually allow people to have insurance contracts against bad weather for their farm, or they can't ship goods because they're not sure if they're going to get paid. And the local legal system perhaps isn't able to give them assurances, and therefore they can't conduct certain types of commerce. But the reality is that I feel like what our space is really about is it's about making a technologically enforced system of contracts that is so well technologically enforced that in places where the traditional legal system isn't able to create the right assurances or to create the right transparency, you would have a technologically enforced system of contracts that allows people in emerging countries to have entirely new types of contracts like crop insurance. And in developed markets, you arrive at a system that basically forces certain levels of cybersecurity, anti-fraud, and transparency even to the larger kind of global marketplace, which I have a strong feeling that that's going to help soften the various booms and busts that define the global financial markets. But that's a much larger conversation.
I've heard you describe this in another way, which I think is a really good way to understand what a smart contract is. So at the moment, we live in a probabilistic world, right? And so that just means that if two people in the world today have a contract, and it could be a legal contract on a piece of paper, or it could be a digital contract, but there's not always a way to enforce those contracts because you're just kind of relying on the good faith and the good trust of the person at the other end of that contract to fulfill their end of the bargain. But if they don't want to, it can be hard to chase that up. So talk to me, what do you mean when you say a smart contract takes us from a probabilistic world to a deterministic world?
What I mean is that you suddenly have agreements that you know will work properly in the most general terms. In more specific terms, if you look at something like Bitcoin as the canonical initial example, you look at Bitcoin and you see a system where you have private public key pairs. And if you have a private key, you definitively always 100% of the time control the token connected and assigned to that public key, private key pair. Now, this is distinctly different from money you have in a bank account, because even as of a few years ago, there's situations where, for example, in Greece, there was a short period where you could only withdraw 66 euros from an ATM as an institution or an individual. And during the time when you saw people only being able to withdraw 66 euros per day as an individual or a business entity, you saw the amount of Bitcoin wallet registrations go up 300% in Greece. But in neighboring countries where such a problem hadn't happened, where it was very possible, you saw those wallet registration numbers go up 600%. I think the real thing here is reliability of an agreement is something that only a certain subset of people really think about. They think about their current agreements and some of their current guarantees as being very strong, when in reality, they're not very strong. And the only people that are very cognizant of this are either the people involved in the back end and middle office administration of these agreements, or the people who have had them fail, or in many cases, the people that, they look at a neighboring economy and they see the ability to get crop insurance, and they look at their local economy and they see that they cannot insure themselves against lack of rain, which is actually the basis for a lot of financial contracts It was the basis of people managing risk as a business that does fundamental things like create food. What smart contracts really do is they take us from this world where we rely on systems that can't provide us the guarantees that we want, even if we're assuming we have those guarantees, right? It doesn't mean we have them. And in many cases, we find out about them in very difficult ways, such as the 2008 financial crisis and many other similar, more personal situations where certain contracts just don't do what we think they do. But even more importantly, I think the really cool thing is there's entire categories of economic activity that we take for granted that if you had a reliable contract, you wouldn't really think about it. But if you didn't have a reliable contract, you would really wonder about it. Like one of the things that got me super excited about Bitcoin when I was getting into the space was I saw some of these folks that were building crypto wallets for the transfer of Bitcoin with feature phones. So this means that people in a country that just got a telecom network and they just recently got feature phones, right? Not smartphones. These people, through this application, were able to send Bitcoin to each other, even though their local system of contract didn't give them a savings account. Because they have a feature phone and they have a parallel system that can reliably give them control of some kind of asset, they can have a place to store value. And it's so good that they can actually, for extremely minuscule amounts of money, send that value across the mountains to their cousin who also now recently got a feature phone. And the local legal system didn't have to do that for them, right? What did that for them was two technologies: the telecommunications industry ability to provide them a feature phone, and the cryptocurrencies industry ability to give them a reliable form of ownership that they could use to store value or transact or do something like that. When you have that, you take it for granted. But if you actually think about a lot of the things that we have in our society, a lot of them are based on the capacity to do these contracts. I feel pretty strongly that if we give that capacity to a lot of other people, it'll really improve what they can do. Likewise, our capacity to have good contracts can also be improved, as shown by things like the 2008 financial crisis and other similar failures of how contracts work.
Wow, nice, Sergey. Look, I love how you're so passionate about this. And so on a long enough time frame, smart contracts really will change the world, disrupt people's ability to transact with each other in a much more positive way. To get there, though, Sergey, and this is where we start to move towards Chainlink, for smart contracts to really be useful, there's what's called an oracle problem, right? So for smart contracts, they need a reliable way to connect to real world data about real world events. That's what the oracle problem is. So can you talk more about what you think the oracle problem is and how we solve it and why it's important? So I guess start with, why do smart contracts need to be able to connect to data about real world events?
Yeah, sure. I think there's just a few important things to keep in mind. The first important thing to keep in mind is what is the defining characteristic of a smart contract? If we agree that the defining characteristic is extreme security and reliability guarantees as a form of automated contracts or digital agreement, then we basically say we want to maintain this property, right? If we're going to have a system of contracts that's going to control billions of dollars, we needed to have this property. Then at the same time, we start to think about, well, what categories of contract do we want such a system to be involved in? And when we think about all the categories of contracts, like financial products, savings lending products, insurance products, trade finance products for global trade, we start to see a pattern where we basically see that a lot of these digital agreements exist today in centralized form. They are very events driven. They are based on a market price changing and an interest rate that you get for your savings lending product changing. They are dependent on IoT data telling you whether the heating cooling system in a hotel is working and whether the insurance policy covers, some failure, or weather data for crop insurance, or shipping data and quality of shipment data for trade finance, right? All of these pieces of data are really about proving whether a contractual clause has been fulfilled. You can say it in many different ways, but essentially what we're saying is we have a lot of events, and those events are what we want this highly reliable form of automation to be applied to. Then the question becomes, what are the challenges? We're taking this highly reliable form of automation that we do want to become the way that all of this value is controlled and is ministered. How do we apply it to those events? So this is where the actual, the details and the nature of the oracle problem become quite useful. The fundamental problem is that blockchain networks, the places where smart contracts live and where their state lives and where they kind of execute their logic, their core logic, those networks are purposefully made very limited for their security. Like what Bitcoin does is Bitcoin stores state about one contract, about Bitcoin ownership, right? So it's extremely limited. That's part of the thesis behind its security. And Ethereum slightly expands that and takes slightly more security risks. And it says, I'm going to let you generate many different tokens. But the reason I can let you generate a token and the reason I can keep it reliable is because I keep my environment secure by not allowing it to interact with other environments in certain ways. But what you essentially arrive at is a situation where the system where the contract state exists and changes cannot speak with external systems. Ethereum, Hyperledger, Bitcoin, they can't actually on their own talk to external systems. They need an oracle or a middleware or what we call a secure blockchain middleware like Chainlink. And if you can't get all of these events that you want to write contracts about to a contract, then you can't write the contract about that event. Right? If a smart contract can't know the weather changed or a market price changed, you simply can't have it written about those outcomes. The goal, once again, is to make sure we retain the security of a smart contract while expanding what it's capable of doing into these other categories. It's a complicated goal where you want to make sure you retain a lot of the security guarantees, but you want to expand what a smart contract does. So you create more attack surface area. And this additional attack surface area is the oracle. And the oracle, in our case, is secured through decentralization, trusted execution environments, the use of zero-knowledge proofs, reputation systems, all these types of things. I can get into more detail on that, but it's equally important to understand that the reason that the space right now, our industry, is so defined by tokens is because for the last couple of years, that's primarily what the technology was capable of doing for people. It was capable of generating a token. If we can get our space building use cases for all these other categories of contracts, my expectation, kind of my hope and the body of work we're involved in is that that'll redefine what our space is about, right? So our space will go from being 90% tokens to being 10% other contracts to maybe 90% other contracts and 10% tokens. And that doesn't mean, there's some kind of adversarial dynamic. It means that overall, the amount of things people can build will massively increase once they can build them around all these events. That's the goal that an oracle has, a high quality oracle, is it allows them to connect events to their contract code. And that allows them to build a contract around those events, very importantly, while maintaining the security guarantees of a smart contract.
That's exactly right, Sergey, and I think you've explained that quite well and quite some detail. For a smart contract to be useful, for us to be able to unleash the real potential of a smart contract, as you say, these contracts, because a smart contract is not smart. It's just a dumb piece of computer code. That's what it is. So for it to have use, it needs to be able to firstly connect it to real world data, but just as importantly, those data sources, there need to be a lot of them. They need to be decentralized, because otherwise, if there's just one source of data, that's a single point of failure and it doesn't solve any of our problems. I hope everyone is with us so far.
I just want to clarify one quick thing. I don't mean to diminish all the progress we've made in our space. I think the progress we've made is massive, and all the great work Ethereum has done and Bitcoin has started. And the fact that we can even have this form of ownership, I think, is absolutely great. But I also think that there's a lot more that we can do with our space. But I just want to be clear. I don't think that smart contracts are quote unquote dumb. I think tokenization is a very useful thing. But even tokenization can be improved by connecting it with external events.
That's right. And another way of understanding this, Sergey, is, as we build out the blockchain ecosystem, there's so many different non-compatible blockchains. And yet, meanwhile, out in the rest of the internet, there's this incredibly rich, detailed set of APIs, right, that can provide data about a lot of different things. They exist already. But the key is making all this stuff interoperable. So the APIs, the data set, that needs to be able to talk to the blockchains, right? And that's really what Chainlink is all about.
Yeah, that's right.
Okay, so that's how we can potentially start to unlock some of the value beyond, as you say, the tokens that we've seen so far. Well, let's talk real world examples then, Sergey. So, particularly this year, 2019, we're almost at the end of the year, and boy, am I excited about 2020, the next decade. This year, we've seen enterprises, institutions, and exchanges. Everyone is increasingly interested in creating crypto derivatives products and other complex financial and legal instruments and contracts. We've seen the rise of DeFi, decentralized finance, DEXs, decentralized exchanges. All of the stuff is really exciting, but for everything to work to their full potential, we need two things, right? We need high quality, institutional grade market data. That is Brave New Coin's field of expertise. That's what we do. This data, it also needs to be integrated into all these products, these complex financial instruments. And one of the ways that we can do this is through Chainlinks, through oracles, right?
Yeah, that's right. I think it's a kind of a nuanced problem, but I think it's very important because in the early stages of many spaces, essentially middleware, or in our case, very secure middleware, it plays an important role because it allows people to build all kinds of useful things. And I think the rise of DeFi is seeing a lot of useful implementation of various market data to make these financial products. So I think you need high quality data providers like BNC. You need a high quality Oracle mechanism. You need high quality teams that are building good products, and you also need a large base of users that want to interact with those products. I think that's one of the coolest things I've seen recently. Is I feel like our space has finally reached a size where if you make some kind of product for the crypto community can sustain that product kind of on its own. Like you can have a successful dApp or smart contract or some kind of financial product that you make. And now there's enough people that you put it out into the market and they can use it. There's the teams building, there's the users consuming, there's infrastructure like Ethereum and Chainlink that are providing the ability for the teams to build things. And then in the case of these more complex contracts, there's definitely the data providers that are allowing us to build these highly reliable contracts.
Okay, so Sergey, as I understand it, you can see this on your website, but one of the first Chainlink Oracle networks to go live on mainnet, and it went live on Ethereum, is, I believe it's called the Crypto Asset Market Data Oracle.
It's for ETH/USD price.
Correct, yes. Talk me through a use case for this Oracle then, because if you look through the Oracle, you can see that it's made up of inputs or APIs, I believe, from Binance, CoinMarketCap, Brave New Coin, that's us, Crypto Compare, and some others. So the idea is all these different data providers are providing crypto asset market data. So what's the use case here? Who would be the end user or the client or the customer for this market data oracle?
Yeah, sure. What we're actually doing is, in this case, we have ahead of schedule, have reached our goal of having 21 independent node operators that are Sybil resistant, so you can know that they're separate from each other. They're security reviewed, and they basically ping a multitude of different data sources. They primarily go to aggregators like BNC, and they get a value, and they put that value in an aggregated form to arrive at one final price for something like ETH/USD price. And that ETH/USD price is then put on chain. The reason that it's important that it's on chain is that the contracts consuming it can only consume it from within the environment where they live, which in this case would be Ethereum. And the use cases for this are all kinds of financial products that people are building, things that they need to market, things that need to be settled daily, things that need to be rebalanced on the basis of the ETH/USD price. And basically what we're able to do with our great group of node operators and data providers is make a highly reliable on-chain reference data price. And that on-chain reference data price is something that somebody can come and use to build a high quality decentralized financial product quickly and easily in a way that the Oracle problem doesn't slow them down. So the historic problem has been, I want to build some kind of financial product or insurance product or trade finance product, and I don't have access to the data. If I get access to the data, I then need to get it on chain, which is actually a much bigger hurdle than people think, because doing it in a way that maintains the security of a smart contract is quite a large undertaking. Now we're kind of in a place where if you want to build a DeFi product around something like ETH/USD price, you could show up, get the price on chain, build the product extremely quickly, and be on your way to building the next market or the next product. It actually brings the space much closer to how web developers build. And if we can have smart contract teams and smart contract developers building with the same large collection of resources like external APIs and external resources that web developers have, then the speed at which things can get built in our space will, in my opinion, massively accelerate. What you'll basically see is that instead of people spending weeks or months figuring out how to get one single data input into their smart contract securely, they'll use better and better made smart contract languages to write secure smart contracts quicker and quicker. And they'll have more and more on-chain data for those contracts to be triggered by. What that'll result in is a massive acceleration in how quickly people can iterate and improve and build all the use cases that we think will go on to define our space.
All right, let's go to a quick break, Sergey, and then when we come back, I want to just quickly run through some of the different components of the Chainlink ecosystem.
Great. Sounds good.
Crypto, the asset class that doesn't sleep. The markets move quickly with profits made and lost around the clock. It's a whirlwind and you've got to keep up. You need enhanced tools that deliver timely data and accurate analytics so you can make informed decisions. You need BNC Pro, a customizable, institutional-grade suite of applications to help you manage your crypto investments all in one place. Get accurate market data, track your trades or custom holdings, and see profit and loss at a glance. Monitor any asset, trading pair, or exchange using Brave New Coin's trusted market data. Integrate BNC Newsfeed and filter it to deliver only the news that matters to you. Never miss an opportunity, save time, and make better informed decisions. Finally, the all-in-one terminal experience you need to master this brave new asset class. BNC Pro, launching Q4 2019. Join the waitlist today at bravenewcoin.com.
Okay, Sergey, so I said we'd run through the Chainlink ecosystem really quickly, so let's just start to do that. Firstly, can you tell me a little bit about what Town Crier is? And this is in collaboration with, I think, Ari Jules, who's the professor of computer science at Cornell University. So what is Town Crier?
Town Crier is our approach to implementing something called trusted execution environments. Trusted execution environments use a separate space of memory and processing capabilities to do highly trustworthy, highly reliable computations. Our use of Town Crier is part of something called the defense in depth security strategy, where the way our oracles actually achieve security is through layering on multiple security approaches and then actually giving consumers of the oracle the choice to configure what amount of security they want. Initially, you can always use multiple Chainlink node operators. You can have proof about their Sybil resistance and their reliability. But on top of that, you can layer on something called Town Crier, which is the use of trusted execution environments. If you start out at decentralization as the basic level, and then you go up to trusted execution environments, and then you gain other guarantees from zero knowledge proofs, and then you gain other guarantees from crypto economic guarantees related to things like staking, you essentially arrive at a system that has what's called more robust security. So that's kind of what we seek to do. We view ourselves largely as a security company that's focused on making sure that we can combine these approaches in a way that gives the user a choice about the amount of security they want in the inputs that go into their contracts. Town Crier is basically our approach to implementing an additional layer of security on top of decentralization in the form of trusted execution environments.
And then you have something called Honeycomb, and I've had a quick look at this today. And so Honeycomb, it's a marketplace for dApps and APIs. So what's the solution that Honeycomb is providing?
Right. What Honeycomb does is it does some interesting work with getting high quality data providers onto the Chainlink network. What we're really trying to achieve is we're trying to get to a place where both through the efforts of individual teams, the larger community, users of specific data feeds, data providers themselves, we have a very large collection of pre-integrated data sources, payment sources, and even computational resources, right? What we're trying to achieve is basically a large global marketplace where anybody can sell data, anybody can sell computational resources, anybody can sell payments capabilities to a smart contract. Because the smart contract has to consume all of these resources through an oracle. And that's a lot of what Chainlink does, is it makes the relationship between a smart contract and the external resources it's consuming extremely formalized, extremely guaranteed, secure, and kind of highly provable, so that a person who builds a smart contract that uses a Chainlink for a specific data source or a specific payments resource, they can actually turn around to their user and show them an end-to-end architecture that proves levels of security. What Honeycomb and other great folks do is they make sure that high-quality data providers are part of the Chainlink network, and a lot of those data providers, as they get consumed more and more, they actually give rise to a virtuous cycle where you have people building high-quality use cases as more high-quality data appears. In addition to Honeycomb, we actually also have a lot of other great ecosystem companies as well. Companies like the Chainlink marketplace, market.link, where developers can actually go and see a lot of high quality adapters and specific jobs and computations that Chainlinks can do for them. I'm very happy and I'm very grateful for all the different ecosystem companies. I unfortunately don't have enough time to mention all of them, but things like Honeycomb and things like the Chainlink marketplace made by Linkpool and many other great things, they really are starting to put together a lot of very useful resources that are helping make Chainlink more usable, helping put more data on the network, and helping kind of developers get access to that in a very useful way.
Fantastic. And Sergey, I know that Chainlink is also collaborating with a variety of other companies such as Google, Oracle, Swift, Hedera, exchanges like Binance. It must be interesting that companies like this see some value in the Chainlink technology proposition.
Yeah, I think it's different with everybody all on different timelines. I think there's kind of two parallel worlds. There's the public blockchain world where you have development teams quickly building dApps and seeking to provide high quality products to either the crypto community or the larger ecosystem. And then you have different enterprises that have their own ideas about the type of smart contracts they want to build. Realistically, I think the good thing about Chainlink is that we can basically help all of these groups, and actually as we help one group, it makes it easier for us to help the other. So I think what we do for the public chains is we provide a lot of these external resources by making these oracles that make those resources available as smart contracts. And as we integrate every subsequent public chain, as we provide oracles on more and more different chains, we can actually turn around to enterprises and give them a middleware that allows them to interact with multiple chains through one integration, right? I think there's actually these two kind of parallel worlds of public chains and enterprise. But I see that a lot of the things that we do in public chain land lead us to make a better enterprise product. And a lot of the integrations that happen in enterprise with enterprise data providers or enterprise payment systems or even enterprise use cases, they give us resources that we can then end up providing to the public chains. Eventually, I think a lot of this will come to a situation where you have large global chains that kind of work between each other and want to consume all kinds of high quality resources. So I think I'm very excited that we can collaborate both with public chain teams that can move very quickly and build these great kind of next generation use cases, and enterprises that need access to lots of different chains for their smart contracts to interact even with their own backend and for all the different data they need.
Sergey, here's something that I don't quite understand. So as we start to unlock the value of smart contracts, is there a way to stop a single point of failure? So for example, if there was a smart contract that was based on insurance, what is to stop me if I've insured my car via a smart contract, but I'm feeling particularly devious and cunning? What's to stop me from crashing my car? How do you code that into a contract? And I guess what I'm saying is, how do you solve for human deviousness in this context?
I mean, I think what our space is about making systems that can deal with those situations, and those systems need to evolve and be able to solve this problem for very specific situations by implementing specific design patterns. I guess what I'm saying is there's situations where if one person has complete control over something, then it's maybe not possible to eliminate that risk. There's other situations where one sensor has complete control over an outcome. But I think the very hopeful thing, and I think the very logical thing, is even when you look at more traditional systems, once those systems start to secure enough value, decentralization of these specific risks is actually a very natural design pattern. If you look at things like space shuttles have a multitude of redundant sensors, right? And they started doing this from very early days of their architecture because the value of what these sensors are related to is so high, you literally had multiple redundant sensors. Right? Likewise, when you look at something like the LIBOR rate, that's made by a panel of 8 to 11 banks, and it's made by multiple banks because at the end of the day, there's approximately anywhere from $100 to $200 trillion in annual kind of derivatives contract value that's controlled by that rate. So I think there are going to be cases where smart contracts aren't applicable. Like there isn't an ability for a smart contract to tell if somebody painted your house the right color blue because there's no data feed for that. Or there's certain contracts that, because one party has too much control, that's not really a good, reliable contract. I think what we're really doing is we're allowing people to write better and better contracts. And then what I think we'll see is that if the data sources become such a critical piece of the reliability of a contract, you're going to see data sources have a lot of built-in redundancy. You're going to see something like the insurance policy for a solar panel field be driven not by one sensor in that solar panel field, but by one sensor every 5 solar panels, right? Because what I already know happens in the insurance industry and what I've seen happen is in many cases, insurance companies, they implement sensors for their clients in order to give them certain types of insurance. And the reason they do that is because the value of what they're insuring and the payouts there are sufficiently high to justify implementing more sensors. I think there's many use cases where smart contract is uniquely capable of solving certain trust issues and certain contract issues. And the improvement of data sources and the solving of certain security loopholes is very doable as long as the economic reasons for doing that are there. I think in many cases they are there.
Finally then, Sergey, talk to me about timeframes. Where are we at? We talked about how one of the first oracles deployed on the Ethereum mainnet was Crypto Market Data Oracle. How far do we have to go before we can start to see meaningful impact around the world and really try and disrupt the contract space? Where are we at and where are we going and how long is it going to take?
I think what I'm seeing now is there's a few key components coming into place. One of the key components is that the crypto community as a user base has grown large enough and sophisticated enough and interested enough in using some of these financial products. You can literally see certain DeFi applications that cater only to our community, that don't need to go out and convince a bank. They don't need to go out and convince an insurance company. They don't need to go out and convince anybody. There's a big difference when you're building an application where you have to go get the users, or if there's already a user base and you just offer users that application, right? Like you just publish your application on the iPhone. And if it's a good application, people use it. They're already in this ecosystem. So I think one of the most critical things that I'm seeing recently is I'm seeing enough people that want to use all these different systems and financial products in a way that you can achieve success as a developer of these products. That, I think, is a huge step forward. I'm seeing a very large improvement in infrastructure. I'm seeing a lot of really smart people working on different facets of the infrastructure, everything from where the smart contract state lives, to how oracles work, to how privacy works. I'm seeing a good amount of qualified people working on high quality applications, and I'm seeing a user base that can consume those applications to the point that team can live and exist and even achieve a measure of success, which encourages other teams to come in and build more applications. I think your question is more along the lines of like, when is something going to go mainstream or that type of thing. I'm not very good at predicting that. I don't think I'm a very good source of insight about when. The good thing is the companies that are doing things the right way have enough resources to basically build great applications for the crypto community until something happens that shows people the usefulness of this approach compared to other approaches. I don't know when that's going to happen. But I think the good thing is that a lot of the great companies that are building the infrastructure and even a lot of the teams building the applications that people would use in the mainstream, I'm glad to see that they have enough resources to exist long enough to reach a point where mainstream adoption happens. Our industry has a large enough localized user base to have good applications and have a story of success that encourages other people to build those applications. And the fact that the companies building the infrastructure and building the applications now have enough resources to be around in a very usable, high quality manner when things do go mainstream. Those two things I can say are definite improvements over previous years.
Excellent. Thank you for sharing your thoughts there, Sergey. Let's go to another quick break and then let's finish off with the Crypto Conversation Hot Take Round.
Whether you're an enterprise fund manager or a retail trader, buying and selling cryptocurrencies successfully requires price discovery you can rely on. Brave New Coin's liquid indices provide trusted US dollar prices for Bitcoin, Ethereum, and Ripple. Featuring end-of-day or intraday outputs, you can count on the BLX, ELX, and XRPLX for accurate US dollar pricing for smart contract oracles, settlement price discovery, net asset valuation, and performance analysis. Visit bravenewcoin.com to find out more.
Sergey, I like to finish each Crypto Conversation podcast with a very quick round of rapid-fire crypto hot takes. Are you up for it?
Yeah, sure.
I want your hot takes. Here we go. Sergey Nazarov from Chainlink. Bill Gates famously said, "We tend to overestimate what we can accomplish in 2 years and underestimate what we can accomplish in 10. I know you're not great at predictions, but what do you think the blockchain space looks like in 10 years' time?
My own personal opinion is I think at the end of the day, a lot of agreements are going to be required to be done this way because the alternative simply doesn't provide the guarantees that any rational person would want if they could get them, right? So I think in 10 years, we're in a place where the infrastructure, the many use cases that make this usable, the guarantees that people get from systems like these has either become or is on its way to becoming ubiquitous. Because if you actually give any rational actor a choice between a highly reliable agreement that gives them what they're supposed to get in almost all situations, or some kind of agreement that at any point in time could be poorly executed and not give them what they deserve, and there's a huge history of these types of agreements not doing that, I can't imagine why a rational actor having both choices would go for the less reliable one. I think in 10 years, we're at a point where many people require their agreements in digital form that can be made reliable using this technology are made that way.
Well, in 10 years' time, it'll be 2030, so hopefully the humans that are around on the planet then are rational actors. Also, Sergey, William Gibson said the future is here, it's just not evenly distributed. Can you think of an example of the future that's here right now, but most people just aren't really aware of it?
I'm not sure if aware of it is the right term. I think of it more as whether people benefit from something. One of the greatest things that has happened in the recent technological evolution with the internet is how it's changed how the whole world kind of works and how that works both in developed and emerging markets. I think one of the most exciting things for me, there's a lot of contract dynamics that exist in developed markets that people take for granted. And then there's a huge amount of the world where people don't have the ability to have a savings account. People don't have the ability to get insurance. People don't have the ability to engage in certain commerce because they just can't form that agreement because there's no bank or there's no entity there that can do that for them because the local legal system doesn't allow that, basically. I think the way in which the future gets more evenly distributed, perhaps in one of the most significant ways, is that you can now transact and insure yourself against risk and have a savings account in all kinds of places where you can't do that right now. That's one of the most exciting things. The other thing that's also extremely exciting is the capacity to take developed markets and make them work correctly through a technologically enforced manner. I think there's a few people that can see how that works, and there's a few people pushing for that, and there's going to be some amount of good reasons where people realize that the reliability in developed markets is extremely important, and the ability for people to do certain types of contracts in all kinds of emerging markets is an obvious and even necessary part of how people should be able to kind of pursue their economic destiny in those places.
Very nicely said. And finally, Sergey, I ask every guest this question to finish off the podcast. What is your favorite science fiction book, film, or show?
I think it's difficult to think of them in this book show format. I think of them as universes. So there's different, there's like the Star Wars universe and the Star Trek universe, and now the Expanse. I'm a huge fan of sci-fi. Really, for me, I think in many cases, science fiction, writing and film, and even games and all these things, they kind of give you a glimpse into the future, and it's just extremely exciting to see that. I think it's extremely difficult to choose one. But at the end of the day, I think that Star Trek, and specifically something like Star Trek The Next Generation with like Jean-Luc Picard and like all those folks, it gives a very compelling look into the future where economic scarcity is eliminated. And what people are doing is they're pursuing knowledge and they're pursuing self-improvement and they're pursuing improvement of society because economic scarcity has been eliminated. And there actually isn't even money. There aren't all these things that we spend all this time worrying about because technology has allowed us to get to a point where we don't need to spend our time on all that. If I had to choose one, I think one of the most compelling ones is Star Trek The Next Generation. But I think The Expanse is also really, really cool. It's just not as positive, I would say.
That's right, Sergey. I'm halfway through season 1 of The Expanse at the moment myself. And I love that you've said Star Trek because Fran Striner, who is the founder of Brave New Coin, and I think you know Fran, but he is a major Star Trek geek as well. Have you ever talked Star Trek with Fran?
No, I haven't. I'm going to. Yeah, I've known him for years, and Fran and BNC have always been very supportive of oracles and this next generation contracts movement. And, it's been great talking with him in the past. And he's, him and BNC are a great group of folks. No, I didn't know that I was super into that. But I think generally speaking, a lot of tech people, they're into sci-fi, maybe for the same reason. I mean, I just see it as a window into the future where you can imagine like what the world would be like if we're able to get technology to do all the cool things we want to do. And I think, I don't know, I'm personally very excited about that.
Yeah, me too. I always say that, science fiction is about trying out all the different possible futures that are available to us as a species, both utopian and dystopian. And look, who knows where it will go. Thank you so much for talking to me today, Sergey. I really enjoyed our chat. Thank you.
It was my pleasure, Andy. Thank you very much.
Well, there you go, everyone. What did you think of that? Did you enjoy that? I hope so. Sergey is so passionate about smart contracts and oracles and blockchain development, and he has obviously spent a lot of time thinking about all of this. This is one of those podcasts where I'll admit I missed some of the nuance of what Sergey was saying when we were talking and recording, but listening back to the podcast during the edit process, I came away quite impressed with Sergey's vision, and I'm excited to see what him and his team can build in the years ahead. Also really enjoyed talking to Sergey about Star Trek and sci-fi, and I think Sergey is exactly right. That is the best way to approach the subject. It is all about universes. That makes perfect sense to me. I may even start using that. And look, I've said this before, but, we do have a strong Star Trek connection here at Brave New Coin. Fran Striner, listen to his episode. We really talk Star Trek in that episode as well, and it's one of the reasons, or the reason, why some of the Brave New Coin meeting rooms are named after elements of the Star Trek universe. I'm sitting in the holodeck right now. The holodeck is where the Crypto Conversation podcast is recorded from. So, hey, shout out to any Star Trekkies out there. Let's finish this off. Let's wrap this up. Links are in the show notes to the Chainlink websites and social media platforms, and also a link to that Nick Szabo essay I mentioned from way back in 1994. All right, we're out of here. This was the Crypto Conversation for Brave New Coin.